And I want to welcome you all as well. And obviously our speaker, Dr. Lori Dengler, whom you are probably familiar with at this stage because she's given a number of big lunches now, for which we're tremendously appreciative. She's an emeritus professor of geology at Cal Poly Humboldt, an expert in earthquake and tsunami hazards and hazard mitigation. Since retiring from teaching, she continues to provide scientific advice to the Redwood Coast Tsunami Work Group, engage in earthquake and tsunami outreach projects with California Office of Emergency Services, and writes the Not My Fault column that appears in the Eureka Times Standard most Sundays. She received her bachelor's, master's, and PhD degrees in geophysics from the University of California at Berkeley and taught the HSU Geology Department from 1978 to 2015. I hope I have that right. She was a member of the team that developed the U.S. National Tsunami Hazards Program and has participated in 6 international post-tsunami survey teams. She was recognized as HSU Scholar of the Year in 2008, received California's Alquist Medal for earthquake mitigation efforts in 2009, and was recognized with the Frank Press Award from the Seismological Society of America for public service in 2017. In 2015, she published a children's book about a tsunami debris boat that connected cities in Japan and California, and has developed a K-12 curriculum based on that. We're very happy to have you here, and we're talking about a whole new subject. So Lori, it's your turn.
Thank you very much. Let's see now if I can overcome the technical limitations, and hopefully everybody now can see my screen. And
yes, we can.
Okay, that's
good.
And now let's see if it will play my PowerPoint. There we go. Okay. That was the hardest part for me. Any rate, thank you again for asking me. I love this forum. I wish I could see everybody's face in person. But it's great to be able to share different tidbits that Mother Nature throws my way. And today I'm going to be focusing on tsunamis, which is quite appropriate since this begins Tsunami Preparedness Week in California. The last full week of March is the time when California really focuses on what a tsunami is, how you might find out one is coming, and how to protect yourself. And this is a really appropriate talk because on January 15th of last year, we got quite a surprise and made us all realize that we're still on the steep part of the tsunami learning curve. So I'm going to start out with acknowledging the fact that every one of you, unless you happen to be in Europe or are on First Nation lands. And this is particularly appropriate and important when we're talking about tsunami, because we have a very, very short historic record. And the map here was compiled by Vicky Ozaki when she was working at Redwood National and State Parks from Deborah Carver's research of the oral history of the First Nations of our area. And here you can see the outlines of, in particular, the Yurok, the Tolowa, and the Wiyot, the coastal peoples that Deborah really focused on the oral history of. And written in black here along the coast, you'll see a number of areas with an E or a T after it. Now, the E stands for an earthquake story, and the T stands for a tsunami account from various different places that were long before any people of European contact made it to this area. And it should be pretty clear that the peoples who lived here were very aware of earthquake and tsunami. I'd argue perhaps a little more aware than we are today. And they recounted their experiences to one another as a form of education. And so in a sense, I am following in the tradition of these people in recounting the experience of a tsunami that really did profoundly affect us, and we need to learn from it. I also want to note that we would know far more about the earthquake and tsunami history of our area if we had been very different in our bludgeoning approach to conquest and erasure of the traditions of the people who knew far more about our areas than we did. We have scraps of those oral traditions, but we certainly would know a lot more about the last great earthquake and tsunami locally here, namely the one in 1700, if we had paid far more attention to what they had to say. Second most important message, tsunamis are tricky. I'm going to say that over and over again. And if you've heard other talks from me, you will probably have seen this slide before. Most important when the ground starts shaking is to protect yourself. And if it happens to start shaking right now in the middle of the day, the most important thing is not to bolt out the door, to stay where you are. And if you have better knees than I do, you want to get down under your desk or table, hang on until the shaking's over. If you are of my generation and getting on your knees is not the best thing to do, just stay where you are. If you freeze and you cover the back of your neck with your arm, you're going to be fine. Shaking is the first warning you are going to get of a potentially tsunamigenic event. So consider the shaking your siren. And if you are in a tsunami zone, please go to high ground or inland as soon as you can safely move, and then stay there, stay there, stay there. Tsunamis are a relatively infrequent event, obviously potentially catastrophic. Far more often, other coastal hazards. Please be aware of sneaker waves and large waves and so forth. Treat our coasts with respect. Also, I am only one person of an army of people that have been working on earthquake and tsunami safety on the North Coast. Here's just a few of the groups that are part of the Redwood Coast Tsunami Work Group. And I really want to shout out, particularly for this talk, Ryan Aylward and Troy Nicolini from the National Weather Service office. Ryan was the one who awoke me a little after 4:30 a.m. on June 15th and really got me into this tsunami. I certainly have to thank Amanda Admire, who keeps our website going, colleagues Rick Wilson and Jay Patton at the California Geological Survey, lots of folks, seismologists, but Peggy Hellweg in particular from UC Berkeley. Big shout out to my OES colleagues and Yvette Leduc in particular, and a gazillion people at the tsunami warning centers. So a little bit of tsunami basics. because people really do get confused by what a tsunami is. We call it a wave, yet it really doesn't look like a wave at all. I prefer to call it a surge. And because this is Tsunami Awareness Week, it's important that tsunamis, that you realize that you're not going to see a great big wave out there. You're not going to see something you can surf. Tsunamis are much longer in terms of period from peak to peak, and they more often look like a sort of rushing, a river in flood rushing towards you, or a sloping wall of water. And frequently, they won't even really look like that, just very, very strong currents. So they're tricky. They're a series of surges spaced minutes to an hour or more apart. And just when you think they're over, another surge will come in. Now, I'm going to illustrate the 2011 tsunami. It's actually not my illustration. It's colleagues at the Pacific Tsunami Warning Center who've created this animation. And you can see this wave front, but you can see a whole lot of ripples behind it. Took about 9.5 hours for the first surge to arrive on March 11th, 2011. And then they continued to arrive for a very, very, very long time afterwards. And tsunamis are very directional. They tend to produce the most energy in certain directions, and you can kind of see this. This is sort of an amplitude plot, and you can see how there's this sort of finger of higher energy, but you can also see this higher energy that's hits the North Coast. This is to sort of illustrate what we knew on the morning, January 14th, 15th, 2022. We had a very good understanding of how tsunamis propagate, how fast they travel, and even how seafloor topography can affect how that tsunami travels. The forecast peak amplitude for Crescent City that day was 2.5 meters. The actual recording, I think, was 2.49. Amazingly close. We understood tsunamis, right? Not quite. Let me go on to the next. There we go. So this is a tsunami travel time map, which you can pull off of websites. And this one shows the time it takes for a tsunami to travel from anywhere in the Pacific to Crescent City, which is roughly the same as Humboldt County. So if we have a tsunami coming to us from Japan, as it did in 2011, you can see that we're in between the 9 and the 10 lines. So it took about 9.5 hours for the first surge. We continued to record it for 6 days. So got to realize they last for a long time. If we were to have a big explosion in Hawaii, a collapse of part of the Hawaiian Islands, which is very unlikely, it would take about 5 hours for the first surge to get to us. Up in Alaska, we've got a little less time, more like 4 to 5, depending upon where along the Aleutian Trench the source is. So if we were to have something produced down Hunga Island, is what I'm talking about, we would expect it to take roughly 11 hours to travel from there to us. The only thing that really affects
Lori, you've frozen.
then it travels, regardless of what that source is, it is going to travel, it's going to roughly follow this map, roughly the speed of a jet airplane. Okay, let's turn to January 15th, 2022. Brief summary. Largest atmospheric explosion ever recorded. Period. Obviously, there have been bigger explosions in the past, but that was before we had instruments to record them. Audibly heard in New Zealand and in Alaska. It produced two different types of tsunamis. I'll get into that a little later on. Tsunami was recorded throughout the Pacific, but it was also recorded in the Caribbean and in the Mediterranean. 6 deaths, 4 in Tonga, 2 in Peru. Tonga was very heavily damaged, and Tonga is still dealing with the aftermath. Damage to boats and harbor structures in Peru, New Zealand, Japan, Hawaii, and Santa Cruz, California. At least 8 Californians were caught in the tsunami. There were 4 different Coast Guard rescues, 3 injuries. And it profoundly changed our perceptions of the tsunami, types of tsunamis we have to deal with. So let's zoom down to Tonga. Most of you, I expect, have not been there. I have a good friend who was in the Peace Corps in Tonga. I really enjoyed her stories. It is south of the sort of in the vicinity of the Fiji Islands, and Tonga owes its existence to volcanic activity. Basically, the volcanism that's created by the subduction of the Pacific plate beneath the Australian plate. And here is the front of the subduction zone. And that subduction process creates volcanic materials that continue to feed these islands. Most of the people in Tonga reside on Tonga Tapu. The largest city is Nuku'alofa, the capital. This is the volcano I'm going to be interested in, Hunga Tonga, Hunga Ha'apai, that is actually the closest active volcano of the current islands to the major population center. Here are 3 Google screen captures of the Hunga Tonga, Hunga Ha'apai area. And back in 2007, you can just barely sort of see these 2 older islands. In 2008, we can see them a little bit better. And these 2 separate islands have given rise to the new island that first basically was created in 2014, 2015 between the 2, and it's called Hunga Ha'apai, Hunga Tonga, Hunga Ha'apai, the combination of those 2 islands. This was not the first eruption of them. In fact, what we're looking at here, this is the remnants, far older remnants of the caldera rim. If you've been to Crater Lake, you've seen a caldera rim. It's the edge with this big sort of collapsed block down between them. So this is sort of your little Crater Lake here. And now that people have gotten much more interested in this volcano, it's quite likely that there were 2 large eruptions back in 200 and 1200 AD. Other documented eruptions, 1912, 1937, 1988, and 2009. So no surprise that eruptions occur. None of the past one, well, it's possible 200 and 1200 were pretty big. There's some evidence for that, don't have good written records. But in the modern era, the eruptions have been relatively modest. Now, keep in track of these two edges, the Hunga Tonga and Hunga Ha'apai, because we're going to see them in this next cross section, which I've stolen from a 2022 publication by Brenna et al. That is a little schematic of what this might look like in cross section. So here we have the two older remnants out there on the edge of the caldera, which is likely to be some kind of a collapse feature, not all that different from Crater Lake. But there's this magma chamber, complex magma chamber at depth, and various feeder tubes. And in 2014, 2015, it built this brand new island, sort of in between the older ones. Now, it's important to realize that all of this is happening beneath the ocean. From the top of this new island down to the bottom of the seafloor, which would be way over here if we looked at it completely in scale, it's over a mile. So you've got this volcanic hotspot, this magma chamber that's relatively shallow, that's beneath a whole lot of ocean water. So this island got a lot of interest after it broke the surface back in 2015. It's not uncommon for volcanic activities to produce a brand new island. There was the famous Surtsey in Iceland. I can remember it as a child, the wonderful articles in National Geographic. It was fascinating. I'm hoping to actually see it, the site of it, this summer when I go to Iceland for the first time. But most of these brand new volcanic islands have very, very short shelf life. They are extremely susceptible to erosion, and the wave activity and weather pretty much erases them in the period of a year or two. This was unusual in that it continued to sit there and actually develop plant life grew on it. And there were expeditions from various countries to examine this process of colonization. But that wasn't going to last. So in December of 2021, a 7-year sort of quiescent period ended with a series of explosions. They were relatively modest, 9 miles into the atmosphere, what we would call a sort of volcanic explosivity index of 2. And a couple of weeks of activity. And by the end of the month, things had pretty much quieted down. 2 weeks into 2022, there was a fairly large eruptive plume that was seen at Nuku'alofa, and they issued a tsunami alert. There was about a 1-foot tsunami recorded in Nuku'alofa. Well, the next day, about a day and a half later, we get the major eruption. We often refer to that as a Plinian eruption, the one that produces the huge clouds that go way up high, named after Pliny the Elder, who perished in the eruption of Vesuvius while copiously recording what he observed in 79 AD. You can find spectacular videos, imageries of that explosion. And online on our own website, here you can see a sign of how explosive these curtain clouds, you've probably seen them in pictures of nuclear explosions. Just a phenomenal blast. And you'll see that at this point, if you had been on Tonga Apatu in Nuku Alofa, day would have quickly become night, and you would have been experiencing a little of what they experienced in Pompeii back in 79 AD. Not as much ash, but it was definitely a biblical event. This is a graphic that NOAA or that NASA put together that illustrates this blast. And it wasn't a single blast. From seismic data, it looks like there were 4 separate pulses. But the highest, okay, our weather lives down here in the troposphere, roughly 6 miles from the ground up. Then we get into the stratosphere between 6 and roughly 30 miles, then into the mesosphere, the thermosphere, and finally out into space. This eruption blasted particulate matter all the way through the stratosphere. It's something we've never, ever observed before, about 36 miles. But particles don't stop. I mean, that's not where the disturbance stops. So we continue to have sound waves and gravity waves in the mesosphere, and it's even producing winds up there in the ionosphere that are detected by satellites. This is not my area of expertise. You can find lots and lots of stuff about the effects in space from the NASA folks. So the reasoning about why this explosion was so energetic, there's two sources of propellant in this case. You have the magma that is coming to the surface, and when pressure is released as it's moving upwards, not only does all the gooey stuff come out, but gases also escape. And so that's what propelled the 79 AD eruption in Pompeii. That's what propelled the Mount St. Helens eruptions. It's just that gas suddenly coming out of solution, like shaking the beer can really, really hard, except for it's a big beer can. But when you have a volcano in the middle of the ocean, you actually have a second source of propellant, namely all that ocean water. And what do you think happens when ocean water comes in contact with magma? Magma is super, super hot. And so the ocean water will flash to steam. And it's something we call a phreatic eruption. It's just steam driven. And most steam driven eruptions are relatively modest because you don't tend to have that much water in contact. But some can be truly catastrophic. And in this case, we had the sort of optimum conditions of the magma, the gas coming out, and then the water in contact with the magma that created this phenomenal blast. The eruption of Krakatoa, which really should be called Krakatau, in the late 1800s, was probably a somewhat bigger version of this same story. So this is a little graphic that was put together by the National Weather Service in Alaska, because there were a number of people who actually heard. I mean, it was certainly heard by many, everybody in Tonga. It was heard in Fiji, it was heard in New Zealand, but we're talking about a distance of 5,800 miles away. And there were a number of people who confirmed hearing this blast in Alaska. This shows the actual recording on the pressure gauge, but a lot of the signal was actually in the audible range. This shows the pressure sensor at Anchorage, which you can see it kind of coming up. Turns out air pressure responds to tides just like ocean does and just like the solid earth. So every day the oceans go up and down and up and down. Well, the air pressure does, and so does the solid earth. And so here you can see the sort of normal tidal fluctuation in pressure with this very distinctive signal of the pressure wave. There are records like this from all over the planet. This eruption affected the atmosphere everywhere on Earth. And in some places, you're able to see that pressure wave go round and round and round 4 times. Still had enough energy in it. What did it do to this little brand new island? Well, fortunately, there's a lot of space-based imagery. So here's what it looked like before the most recent eruptive sequence began. And here it actually built itself up in the December part of this recent eruption. It made it to its sort of maximum size at the new year in 2022. The eruption on January 14th, which was a pretty good size eruption, and most people thought, maybe that's it, pretty much erased most of the island that had started to form in 2014 and 2015. And if you look at a Google image today, it's pretty much gone. There's a little bit of a remnant of the Hunga Tonga and the Hunga Ha'apai, greatly reduced, and nothing is left of the new island. But we can travel across it in research ships and actually map out the shape of the sea floor. So this is the New Zealand NOAA agency's bathymetric map. Now, the only parts of this that are above sea level are these 2 little pieces right here and here. Everything else is below sea level. And here is this great hole, estimated a bit under 2 cubic miles of material that was primarily blasted into the air. Some of it's probably still stuck in the stratosphere. And a lot of it distributed on the seafloor for many miles around. Now, this graphic, again, put together by NOAA, not surprising that the New Zealanders are very into this particular location, is another way of comparing the size of volcanic eruptions by looking at the volume of material that is blasted out. And here we see Mount St. Helens back here, a little less than 3 cubic kilometers, VEI 5. Here we have the largest relatively recent eruption, Pinatubo in the Philippines in 1991. Here we have Krakatau in Indonesia back in 1883, and that was recorded on instruments. People heard it in India, and it also produced a sound wave that went round the world. And then we have historic evidence for much larger eruptions. This is Taupo in New Zealand, that would actually be dwarfed by a couple of eruptions from Yellowstone. In terms of volume, it actually didn't produce a huge amount. As I say, it's the highest we've ever recorded. So now let me focus on the tsunami, because that's what disrupted my sleep on January 15th. So here we have the eruption, and all of the times here are Pacific Standard Time. So it can get very confusing when you're using all of these different times. Generally, when we communicate worldwide, we use Greenwich Mean Time or UTC, Universal Time, so that we're using a standard clock. But because I expect most of you listening were on the West Coast, I've translated everything into PST. So here we have the eruption, and I've actually superimposed it on that travel time graph, which is what we would expect in terms of the tsunami arrival. This is the part of the Pacific that the Pacific Tsunami Warning Center, it's part of their area of responsibility. There are a number of countries in the Pacific that are all sort of joined through the International Oceanographic Coordinating Group to receive tsunami bulletins when a potentially tsunami threatening earthquake, most likely, occurs that could affect them. So the folks at PTWC were actually right on top of this when it happened. It was only about a little more than 2 hours after the eruption that they sent out their first international threat message. Here's where things also get tricky with tsunamis, is that there are a number of different kinds of bulletins. And over here on the West Coast, we're supposed to block our ears and not pay any attention to what PTWC is doing. We get our guidance from the National Tsunami Warning Center up in Palmer, Alaska. And they didn't issue anything in the early hours of this event because we really didn't think it was going to affect the West Coast of the US. So PTWC continues to monitor this, and it continues to be sort of surprising because there actually are a number of instrument gauges on the deep sea floor and then at nearby locations where the tsunami appeared to be bigger than what they were expecting, and the tsunami was also arriving a little more quickly than what they were expecting. Now, the National Tsunami Warning Center gets involved at 3 a.m. and at 4:46 a.m., a tsunami advisory is issued for the West Coast. All right, let me try to explain what these terms are because people get really confused about tsunami terminology. At present, there are 4 different products that our tsunami warning centers issue. And I will say at present because there's a discussion going on right now to perhaps change some of this terminology. The highest level is a warning, and that's going to continue regardless. The highest level is going to be called a warning. And a warning with tsunamis means that we have pretty good confidence that there's really a threat out there and that it could potentially flood areas that are normally above high tide. So a tsunami is imminent, flooding and dangerous currents, and it's up to local jurisdictions to order evacuations. That's the tsunami centers don't order evacuations, but it's the guidance. The second tier is what we currently call an advisory. An advisory means that there could still be a damaging tsunami, but the water is probably not going to get above high tide. And the problems are on beaches and particularly in harbors, where very, very strong currents can rip boats away from moorings and destroy docks and other structures. So in an advisory, we're not going to order a full-scale evacuation of everyone in the tsunami zone for a huge earthquake right here. But we want to get people off beaches and out of harbors. And then the bottom two are really, we're still sort of, a statement means no problem. There's something that happened. We get statements. I got 2 last night. Both were from magnitude 4 earthquakes in Alaska. Just telling me, yeah, these earthquakes happen and there's no tsunami threat. A watch means, you know, there could be something out there, but we've got enough time to keep analyzing it. So really important to understand the difference between advisory and warning. Advisory means we don't want you in the water, and we don't want you on the beach, and we don't want you futzing around in the harbor. A tsunami warning means we want you out of the area where we could get flooding on land. And there were no tsunami warnings issued for the California coast on January 15th. Another area that gets tricky. So this shows the area of responsibility for the 2 US tsunami warning centers. Everything in red is the National Tsunami Warning Center. Everything in orange is the Pacific Tsunami Warning Center. It's fairly straightforward for the National Tsunami Warning Center. They pretty much issue one product that covers both Alaska and the West Coast. We've yet to have an event that involved both the West and the East Coast. There are tsunamis on the East Coast. They do happen, but they're far rarer. But the Pacific Tsunami Warning Center has these international messages. They have Hawaii. They have US territories, and there are a whole bunch of different kinds of messages. And it's important to pay attention to which one is meant for me. So here is an indication. If I'd been working at the Pacific Tsunami Warning Center on January 14th, 15th, that I might start scratching my head. This is the actual merogram from Pago Pago in American Samoa. I've been there. I understand why Pago Pago tends to get an amplified wave. It's a very long, narrow bay. And here you can see the normal tidal fluctuations that you'd see year in, year out. And right there, obviously, there is a much larger amplitude. Now, this actual first arrival is coming in, 20, 30 minutes earlier than what the travel time map would have predicted. And then it continues to arrive for a while. And at that point, people really start scratching their heads. And you have to realize that at this time, at the tsunami warning centers, all of their products require an earthquake magnitude to make them work, because before this day, they had never issued a tsunami message that was not based on an earthquake. So in order to, they didn't have time to rewrite their software. In order to make their messages work, they had to put a magnitude in. So there wasn't a magnitude. So they put in 0.1 and you end up with, they did it with a test message. When the National Tsunami Warning Center got into it, they put in a magnitude of 1.0, which is also ridiculous because you look over here and the bulletin said earthquakes of this size are known to generate tsunamis potentially dangerous to coasts outside the source region. And then they say a magnitude 1.0. If you had been lying on a bed above a 1.0, you wouldn't have even felt it. I mean, but this was the only way they could push the messages out. So at 3 a.m., it's suddenly looking like, yikes, we've got something that is bigger than we expected, is arriving faster than we expected, so we've got to do something about it. Well, that's when I get a text from Ryan Aylward, who is the warning coordination meteorologist for our local weather service office. And his responsibility is to communicate tsunami threat. And he sends a text to me and Troy Nicolini, who is the meteorologist in charge, saying, advisory coming shortly, time for us to get up. And then I talked to Ryan on the phone and he says, there's been this incredible volcanic blast. Of course, I'm groggy. It's about, early morning hours. And at first, it just doesn't seem real. But this is the text of that advisory. And I wasn't in on a lot of the conversations with the OES folks and the weather service folks, because I was very busy dealing with media and social media, trying to communicate what we knew. But it really was puzzling. So at its height, this shows all the areas in orange that were part of the advisory. And again, this is not a warning. This is the hazard is not, it's not going to be flooding the dry land. But we really want to get people off of the beaches, out of harbors, and paying attention. So if you had been a resident of any of the California coast, I'm just showing the Humboldt County notifications, you should have received, I'm signed up for county emergency notifications, and this was the bulletin that I got from county OES. I'm supposed to confirm that I got the message. To illustrate another issue and how tsunamis are tricky, this is actually in error. This message went out saying hazardous waves are expected between now, which was around 6:30 in the morning, and 8 a.m. In fact, 8 a.m. was sort of what was estimated when the surges were going to arrive, and they were going to continue to arrive all day. So this shows you even people who are supposedly in the loop get confused about the message. And I also got a message from what was then Humboldt State University before they became Cal Poly, to stay off of the beach and low-lying areas. Now, it was also disseminated via radio and television. And this is what I ended up spending a lot of my time doing. I found that Facebook is the fastest way to push information out. So I started posting around 5 a.m. This was a 6:23 a.m. post that shows the actual tsunami as it's arriving in Pago Pago. And trying to make it clear to people what's happening, what we know, and to stay off the beaches. So whenever there's an earthquake, tsunami, Facebook is the place I've found the most efficient to push out information. Really important to get your information from a credible source. And now that we have Bard and Chatbot and people can spit out messages that look official, you have to really be careful. So here are 3 recordings from the North Coast of the actual water levels. The 2 largest recordings in California were at Crescent City and Arena Cove. But notice on all of this, this is a day. From here to here is a day. From here to here is a day. We continued to record this even in Humboldt Bay for 4 days. Now, we've also got offshore sensors. These are the 3 DART instruments that are off of the Northern California, Oregon, and Oregon coast. And here you can see the normal high tide coming up. And right about here is a really low level signal. And then there's another signal that's a little bit higher frequency. Similarly down here, the very low signal, and then the higher signal. Well, none of us had ever seen a DART signal like this before, because what we're looking at are actually 2 different kinds of tsunamis. This one is arriving when we expect it to, for traveling, for deformation of the seafloor, traveling in the ocean. This is the part that's early. What caused it? Well, we know that there was damage. Here's just some pictures in Ventura and Santa Cruz. Another issue that we always have a problem with when there is an alert issued is we get lots of onlookers. And unfortunately, it was a nice day in California. It was sort of before the big, kind of a nice day in between. I mean, it was a dry year. It wasn't like this year. People were on the beaches. There were at least 4 Coast Guard rescues, 3 injuries in California. So there were people who were not heeding the advice. So what we now think, having the time to really analyze data, this was so data rich with satellite data, land-based seismic stations. We think that we know that there's this conventional tsunami that's caused by that collapse. You saw that crater that's now where there used to be an island. And that produced the conventional tsunami that traveled at the speed of a jet airplane and arrived when we expected it to. But the atmospheric pressure wave, it actually traveled at the speed of sound, which is quite a bit faster than the speed of the tsunami in the water. And it traveled, it actually was able to travel over Central America. It was recorded in the Caribbean. It was even recorded in the Mediterranean. And the time didn't allow it to travel around the tip of South America. I mean, it managed to get into the Caribbean by that pressure pulse traveling in the atmosphere. So our thought now is that as this pressure wave travels roughly 700 miles per hour, our tsunami's going roughly 450 miles per hour, the one from the collapse. The whole time that pressure wave is traveling, it's coupled with the ocean, and it's actually deforming the entire ocean column, producing a tsunami type of surge. So what we've learned now is that tsunamis are even trickier than what we thought. We're now aware that atmospheric pressure waves from huge explosions can travel as a tsunami and travel more rapidly than our conventional ocean bottom disturbance waves. And we've now fixed that glitch in the tsunami warning centers, that they don't have to force their messages by putting in a fake magnitude. This is now part of the protocol. But there's still a lot that we need to improve on. And it's being worked on. Consistency between the two US tsunami warning centers. At present, they have completely different types of computer systems. That's all going to be changing in the next year or so when we end up with a common protocol for both of them. Communicating the risks for these moderate tsunamis that can certainly do damage and injure people. Trying to get people to stay off the beach and out of the water is a continuing education challenge. And everywhere about tsunamis, we have the education, education, education message. As part of this process, Del Norte, Humboldt, and Mendocino counties will be testing communications for a tsunami event coming from far away this Wednesday between 11 and noon. And so if you are particularly in Humboldt or Del Norte counties, what you are likely to experience around 11 a.m. if you're listening to the radio, it has to be a local radio station. If it's something that's coming out of the Midwest or something, that's not going to work. JPR won't even cover this. So if I like JPR, I like the classical music, they won't be carrying the test. But if you're listening to a local radio station, right around 11 a.m., you should hear some explanation that there's going to be a test. Then you should hear the test tone. Then you'll hear another explanation that it was only a test and you don't have to do anything. If you're watching television, it's a little trickier because for the little bit between the actual test, you'll just see a crawl across your television that says tsunami warning, Del Norte, Humboldt, Mendocino County. And if you aren't aware that it's just a test, you might freak out, jump in your car, which you're not supposed to do, and drive as fast as you can. It's only a test. So it's really important for everyone to understand that it is only a test. If you've signed up for emergency notifications, Humboldt and Del Norte counties will both be using the test to test their Everbridge communication system, but you won't get a message unless you've signed up for it. You can get it via text on your phone, you can get it via email, or you can get a phone call. I really recommend that you sign up for it. In localized coastal areas, you might hear a siren. There's only a few sirens that are currently functioning. Sirens are a really poor, they're a World War II system, and nowadays there's much better ways to communicate threat. But there are some areas in harbors where a siren is useful to get people's attention. You probably won't hear a siren unless you happen to be standing outside the Weather Service office. And if the weather permits, the Civil Air Patrol will be flying one of their planes with an audible message. So multiple ways. And had it been, hopefully the Caltrans signs, like the one I've shown here, will also be telling you about the test and would also communicate information had it been a real event. There are lots of other things happening this week in California. As I say, we have the test on Wednesday here. And if you go to the Redwood Coast Tsunami Workgroup webpage, you can find all sorts of, lots more info about the January 15th, 2022 tsunami. We have a whole webpage on it. And you can also go to the tsunamizone.org, which has a whole long list of events happening this week. So with that, I will wrap it up and I will be happy to take any questions.
Anybody have any questions? Man, I think you were so thorough, it's hard to find something to question. That was really good. My question, however, is what about things like the big explosions in Iceland? Have those created tsunamis that would have them figure out that this was feasible?
Well, that's a really good question. The thing is, they don't produce explosions like this one. I remember Eyjafjallajökull back, was in the 2000s. I'm going to Iceland this summer, and I will definitely have to ask them about explosions. But as far as I know, none of those, I mean, they do have these, large landslide events that have probably produced localized tsunamis. But I haven't heard anything about the atmospheric explosions doing that.
Did Vesuvius, are they aware of whether that created a tsunami?
Yeah, it did. Localized. You can actually go, there's a tsunami database. I can't remember, I'm afraid offhand, I don't remember what the tsunami threat was, but yes, it did produce a localized tsunami in the Mediterranean.
So there are very few records or knowledge of the existence of other ones created by volcanic bursts.
Well, as I said, there's quite a bit of information about Krakatoa, 1883. Yeah. In fact, there's a really interesting book written about that eruption. I can't remember the name of it offhand, but that was actually what I call the first modern natural disaster, because it was the first one after we've got communication systems where in real time they could convey the information via teletype to Europe. And that actually is the origin, why we call it Krakatoa, because it was Krakatau, but when they were typing in the dits and the dots, it was a media spelling error. And so we still tend to call it Krakatoa and not Krakatau. But I don't think there's any question that eruption was more explosive than this one. This one actually tells us a lot about what that was probably like. And I expect that there are researchers that are using the experience of this eruption to go back and re-examine the data from 1883.
And there's a question from Mark Larson. Thank you for your interesting review. I'm wondering if there's a correlation between your tsunami presentations and actually tsunamis occurring not long ago, after similar to your time standard earthquake columns, and earthquakes occurring not long after. And then says, my actual question is, will KHSU FM be carrying the tsunami test?
As I say, Mark, it's not my fault. But KHSU is supposed to be carrying the test. I hope that somebody will listen into KHSU at 11 a.m. and find out if they did carry it. one of the problems in the last couple of years is that KHSU's, see, the signal is digital, but they don't have the equipment to directly translate the EAS signal into digital. It has to go back to analog and then go to digital. And for the last couple of years, KHSU's announcements, real announcements, their tests are just normal, but they're really garbled. So I'm hoping that someone out there will choose to listen to KHSU or whatever other station you happen to like listening to and find out how clear the signal is. This is why this test is so important. And it boggles my mind that very, very few places in the US do what we call a real or live code test. Everyone has heard the weekly tests. You've seen it on your TV, you've heard it on the radio. That takes a completely different route and has a completely different set of codes than the real alert. And that's why you can only find out how the real alert works by testing it. But most areas are terrified that people will confuse it with a real event and then do something stupid. And that's why we are the only place in the entire United States that uses the real code to test how the system works. Why are we bold enough to do that? Well, the nice thing about Mendocino, Humboldt, Del Norte counties is that we're kind of an island and we don't spill into neighboring areas. The Bay Area would be really complicated because it's so big and there's so many people who don't know squat about tsunamis. And we've been working really hard on the North Coast to educate everybody about what tsunamis are. And yes, tsunamis are still tricky, but we have a much higher background level of awareness. And since we first started doing this test in 2008, we've only had a handful of people who call in to dispatch and say, what was that? Is this really a tsunami? Our real challenge is reaching, there's sort of three communities. There's those with hearing impairments. So we've been working really hard to reach the deaf and hard of hearing. Elderly, who are often kind of cut off, especially those people like me living not in a group setting, that are kind of cut off from communications. There's also the people who don't speak English. So we've been really trying to work hard, particularly with the Latinx communities. And actually there's a fourth group, which are people like my son who don't read the paper, who don't listen to national news, who don't listen to local news, who only, listen to their own playlist. And that is an increasingly difficult group to reach. The people who are islanded out in their, kind of own bubble. And I have not really figured out how best to reach that community.
Try TikTok. Why is it that they can't put the fact that the warning is just a warning on a television when they scroll it? That makes no sense.
It's the way EAS is configured for television. You can put it right before and right after, but during the scroll, you can't. Okay.
So it will show up beforehand. Okay.
If you are listening before and after, and I hope somebody will watch some of our local television stations. Again, you're not going to see it if you're watching Netflix. You're not going to see it on any, non-local station.
And Sarah has a question, where the waves of the two types of tsunamis recorded clearly, where can I view the pressure wave signature?
Send me a message, lori.dengler at humboldt.edu, and I will be glad to send you that image. And of course, this whole presentation will be available for anybody to watch in what, a week or two?
Oh, faster than that,
Oh, good.
probably by the end of the week.
Great.
We're speeding things up. Okay, and Kate Hitt said, did the 2022 tsunami create more than one surge?
Oh yeah, I mean, as I said, we recorded it even in the California coast for at least 4 days. So there were dozens of surges. When you consider each, there's roughly on the order of 20 minutes to 40 minutes between successive surges. They're not regular, but yes, there were dozens of surges. And that's true for any tsunami, especially in California. The reason has to do with the California shelf, that once you start getting that energy, that we create an oscillation that is on the shelf. So that's not as true in Hawaii. Hawaii, the duration of this, because the Hawaiian Islands are kind of these gentle sloping cones, the tsunami tends to be over in a period of hours, whereas on the California coast, it's not unusual for our largest surge to arrive 4, 6, 8 hours after the first, and for the wave energy to persist for days.
That's great. We have, as Janina commented, we have this level of tsunami awareness due to your dedication. We thank you. You've been
Well,
writing and talking about it and writing about it forever. It's fabulous. We appreciate
well, I
it.
keep learning something new. As I said, this 2022 event definitely was, I'd argue that was the most exciting new thing I've ever learned about tsunamis. That
The air
wow.
pressure tsunami.
Yeah, that you can actually produce a tsunami from this pressure wave moving in the atmosphere.
I think everybody's saying thank you, thank you, thank you. Does anybody have any more questions? If so, say now or forever hold your peace. Until next week, when we have a talk by Sean McLaughlin and John Richmond, who's publisher of Time Standard. And Sean is head of executive director of Access Humboldt. We'll be talking about the future of local media, how we're endangered we are, and what we can do about it, and what's actually going on. So we hope to see you again next week.
I certainly want to thank the local media folks for giving me a platform.
Well, we're very appreciative to them for giving you that platform. And we're happy to give you this platform whenever you'd like it. So just figure out what you want to talk about next and let me know.
Well, people can put in the chat box what they'd like to hear, and I'll take a look at that.
That's fantastic. Or they can email you.
And they can email me.
That would be, or they can email me, because
Right.
I can harass her about it, which I typically do every few months. We thank you ever so much, and we look forward to seeing you soon. And thanks for spending part of your day with us. And if you have individuals that you think would make great OLLI members, please feel free to let them know about this wonderful program so we can get closer and closer to the 1,000 mark that we need to get. We're not the only OLLI program that is in recovery. It's happened all over the United States, and we made big progress this last year compared to the year before. But we lost something like 40% of our membership as a result of switching over and having everybody kind of hit away. And now you can come back to online classes as well as in-person classes. About 40% of our classes are in person now. And we'd love to have you come back. And you can still pick up you can look online for our catalog at humboldt.edu/OLLI and get the current catalog, or there's still a few copies at Wildberries, and I'm not sure where else, but I know I put a whole bunch there, and I saw about 4 or 5 there this morning. So if you want one in person, you can get one. Janina, have you put some in there? You put more? Yeah. So we're going to say bye-bye now. Thanks so much. We'll see you next week.
Jane, I put more after yours.
Oh, okay. Well, I put a whole lot of them in there.
Not yesterday.
Oh, good.
So, and when I put more in, there were 6 left, and I added 15.
Now there are only 4.
I'll get back there today.
Wonderful. Thank you very much, everybody. Take care.